Okay, so the discs, right? The discs were made out of a microwave casing, outside sheet metal in a microwave. It's just the only thing that I had that was thick enough. So I sacrificed a microwave. And it was out here in the weather for like 2.5 years. So, you know, it's in pretty bad shape. There's cockroach nests inside of it. But anyway, so, and you can see the washers spacing it. You can see there's 2 washers for every disc. We're gonna, once we get either better disc or we get more holes, we're gonna cut that down to 1 washer and have a smaller gap and see how that works. Because it's working, but I feel like it's not as efficient as it could be. So one thing I want to talk about the disc. When we tried to heat treat the disc, I put the whole thing together in a stack. I bolted it together, and I put it in a campfire. And or you could say a kiln, like not quite a normal fire because it had bricks all around it, and I wanted to get as high a temperature as possible. But one thing that actually happened is they had a lot of rust on some of the discs. Some of the microwave was pretty rusty, and all the rust came off in the fire, and it made a very very thin layer of oxide on the steel. And I'm wondering if it might actually be ferrite. So it might be an iron oxide called ferrite, which kind of looks this color. And I'm not sure. I'm not entirely sure, but it's a gray. It's a dark gray. And the one thing about that, though, is that if it really did make ferrite, and by the way, these discs were touching, and so any oxygen that got inside of them was only by virtue of tiny little gaps. And they were not nearly as warped when I put them in as when I took them out. So, you know, live and learn, I guess. But what I'm thinking about is, I originally said, okay, I can only run the turbine 1 time, and then it's going to rust. And so I immediately have to take it apart and try to paint all these discs before I put it back together. I am going to run an experiment, though. I'm going to see if, 3 fire rings, if the disc actually rust or if there's a protective layer of ferrite on the disc. Because I am thinking that actually the discs have been oxidized in such a manner that as long as I don't break it off and scrape it, these discs might be rust resistant because they've gotten wet several times. You can see on this one it's got this white powdery substance. That was the paint. That was like the enamel paint that was on the microwave. So that side was painted. The other side had very little paint, but it had some. And there's rust on the inside of the microwave. So I am thinking there might be ferrite, a super thin layer of ferrite on these. And that's basically like an iron oxide that is pretty stable. You find it inside of magnets, you find it inside of electromagnets. Like if you've ever taken apart a television, a tube TV, you have this high voltage transformer thing, and it has these two ferrite cores. And so magnetic ferrite cores are pretty popular in electrical engineering, and so I have a feeling that the discs actually have a coating of ferrite on them. So, needs to be investigated. I don't know. This definitely does not. This is galvanized. That was from some type of electrical panel it was the thickest piece of metal I was able to find, and I borrowed it from someone, or you could say, it went to a good cause. And so, I am for now just going to kind of put this thing back in here and just store it in my trunk for now. But we will return to this. I don't want these to get dented any more than they already are. Somebody's got a chainsaw. Got a hair in my mouth. So, yeah, we're just going to store these. Try to, keep it from getting damaged. But, I would say for the very first run of the turbine, that was a stunning success. Now, this thing needs to be remade. The hole is way too big. I didn't have it in the right spot when it was inside the housing. And so, just to show how that goes, right? You have this hole. You have your steam nozzle. Remove that. and the steam nozzle fits right in here like that, and then you want to rotate it to where it's as far away from the nozzle on the side that it's coming out from. And so obviously when this thing's when this thing is spinning at speed and vibrating, this could move. And so ideally you would put a you'd put some kind of like a wire or a bolt that holds it down. But anyway, basically like that, you know, and it was keeping the steam. It was keeping the steam into this concentric track where it would have a smooth surface to run against and pick up speed. And so ideally, once this thing is running, you have steam rotating around here at very, very high rate of speed. Basically, whatever's the maximum this nozzle can do, minus the friction coefficient, minus the amount of steam that's actually going through the turbine disc, and that gives you how much is left. So I definitely have to paint the housing. The housing definitely does not have any protection and is just cast iron, and it is going to rust. So I'm going to put this in my car, and we will resume these videos after this Snowmageddon snowstorm thing is over and done with. But just for now, I think that was a pretty good test run. I honestly didn't think I was going to be able to get it to spin. I was like super excited, and I thought about it, it's like, oh, it's probably got too much of a gap, and probably the steam is just going to escape and it's not going to build pressure. But it ran flawlessly once it actually was spinning fast enough. Centripetal force kept the steam on the outside band, and it built pressure and it ran. And I want to say it easily hit 2,000 RPMs. And this is a pretty big diameter. So 2,000 RPMs on that thing is a lot. And these are the outside rings that sandwich everything together and provide pressure. And then you saw a bunch of bolts that were on the perimeter, 10 of them to be exact, because this thing has 30 cogs, and it went every 3. 1, 2, 3, right? So 1, 2, 3, 1, 2, 3. So I have 30 of these little cog things from a transmission, and I have 10 holes. And I just figured that would provide good clamping force. And the housing worked flawlessly. I didn't have any steam escaping through the housing. That can all stay outside, because that's protected. Actually, these things, okay, this is empty, but yeah, keeping things dry is a real challenge out here. We're going to work on that. And the yard looks like a mess. I haven't had time to process anything, honestly. All that stuff is to turn plastic into oil, and there's a bunch of rubbish just waiting for a project. I think we're definitely going to build a Stirling engine next, a hot air engine called Stirling engines. That's one design. There's more than one design, but Stirling was the one who did the initial Carnot cycle as close as possible to the ideal cycle. He made an engine. And there's different designs. There's also something called a rhombic drive, which is a more efficient crank mechanism. The rhombic drive is the way to go. But it's much harder to make than a standard crank, so we'll have to see if I have the materials to make one. But we're definitely going to make a Stirling engine next. That is the reason I have these. This one's empty. I have 2 empty ones. And we're going to have a hot side and a cold side. And that's going to come off, obviously. And I'm going to cut off the ends and put plates so that they can be bolted together. And then we're going to have an insulation. And we're going to have a displacer piston that goes back and forth. And so, I mean, I guess necessity is another invention, because this is kind of all I have to make an engine out of. But eventually we will get to that. This can stay. So, yeah, that is the tour of the little homemade Tesla turbine. And, yeah, I definitely need to get a shelter to put all this stuff under, because it's literally just sitting in my trunk. That's all we have room for. And yeah, we'll see you in the next one. Oh, one final thing is under here, we have the beginnings of a wood gas generator. I have a engine. I've taken the carburetor off. It's just a Honda engine, and it's on very rusty little pieces of signpost that I found in a ditch. And inside the truck, and the truck is as much, if not more, of a mess than the car, unfortunately. But inside the truck, I have an unfinished wood gas generator, downdraft, stratified downdraft wood gas generator. And I guess, okay, this thing, we're going to try and make a little robot. There's pieces of my engine, but what it basically is it's a propane tank that I cut in half, and the bottom of it has, funny enough, a fire extinguisher. Now this is where I need to drill. I need to drill holes and punch that out. And my welding was definitely not the best, but it did work. And the thing about these things is they can produce a lot more torque and more kind of instantaneous power. But to get the maximum efficiency, you would want to take some of the heat that normally gets wasted on. So basically, you put biomass and wood in here, and you use suction from the engine, but to start to use like a vacuum cleaner, and you pull the fire down through the stack of material that's going to be inside the cylinder, and then it burns, and it only partially burns, so it's incomplete combustion, and then it fills this whole thing up with smoke, and then it goes through this filtration process. And they're actually super simple to build. This is the first time I've ever built anything like that, because I lived in a city my whole life. Oops, I forgot to put that. And so, whenever we get the turbine, the generator part constructed, and we're producing power, I think maybe I want to build a second turbine just as a backup, and then we're going to work on these other projects. This door is just freaking terrible. So it's supposed to be freezing and rain all day, today, tomorrow, and then snow. I think tomorrow is the snow, but so I think we're going to call it quits for now, and we will come back to this project. Oh, I got to put up Kevin's thing before it gets wet. So, and my little charger. Literally the only power source I have is this little 150 watt inverter. That I have these other inverters that are broken. I need to fix them. And then I have a 220 volt 6 kilowatt inverter from China, but it only runs on 72 watts. Sorry, 72 volts. It's a 72 volt inverter, and even though I have the batteries to do it, I need it needs to kind of stay in that area because the batteries are too heavy to be moving them around. And so, oh, did I put up? Yeah, so I got some more things. Okay, so we did put up the portable inverter, Kevin's inverter. So we'll see. I was not planning on making a video this long, so I'll cut it. But if you got to this part, that means that you saw the original. So we will return to all this in the very near future. Just a lot of stuff I gotta clean up and recycle. Alright, stay warm.